You are reading this in one universe. That sentence sounds like the opening of a science fiction story. It is not. It is a statement about a genuine, seriously held, mathematically rigorous interpretation of quantum mechanics that was proposed by a Princeton physicist named Hugh Everett in 1957, that has been developed and refined by serious theoretical physicists for nearly 70 years, that is currently one of the leading contenders among physicists for the correct description of quantum reality. And that, if true, means the word universe refers not to everything that exists, but to one particular branch of a vastly larger structure in which every quantum event that could have gone differently has gone differently, in a separate branch right now, without any possibility of communication between branches, without any experimental test that can currently distinguish it from its rivals. You are reading this in one universe. There may be an Everettian sense in which that sentence is literally, physically, mathematically true. But let me ask you something before we go further. Why should you believe it? Not why is it possible. Quantum mechanics is strange enough that many things are possible within its formalism. Why is the many worlds interpretation a serious scientific proposal rather than philosophical speculation dressed in physics clothing? What problem does it solve? What does it predict? And what does it mean for you specifically that if it is correct, every decision you have ever made has also been made differently, in a branch of reality you will never visit, by a version of you that is indistinguishable from you at the quantum level? The answer requires starting from the actual problem that motivated Everett, because without the problem, the solution makes no sense. The answer is going to make the word you feel unstable. Now let's be fair to the skeptical position, because it is the scientifically healthy one. Parallel universes are a staple of science fiction, which means the concept arrives preloaded with cultural baggage that makes serious engagement difficult. The many worlds interpretation sounds like it was designed to be dramatic. Every quantum event spawning infinite universes, each one equally real, none of them accessible to any other. It has the structure of a just-so story, an unfalsifiable multiplication of entities that violates the spirit of Occam's razor. And the honest position of many working physicists is that the interpretation of quantum mechanics is a philosophical question that does not affect the predictions of the theory, and is therefore not a scientific question at all. You might say, if parallel universes make no testable predictions different from other interpretations, then they are not physics. They are metaphysics with equations. And that is a respectable position held by serious people. Let's check what the actual argument for Everett is, because it is stronger and more specific than the popular version suggests. If you want to understand how the universe actually works, not just how it looks, but how it works, hit that subscribe button. We are going to take things apart and see what makes them tick. Let's find things out together. Here is the problem Everett was trying to solve. Quantum mechanics describes the state of a physical system using a wave function, a mathematical object that encodes the probability of finding the system in any particular state when measured. Before measurement, a quantum system can exist in a superposition of multiple states simultaneously. An electron can be spin up and spin down at the same time. A photon can be traveling through both slits simultaneously. A radioactive atom can be both decayed and undecayed simultaneously. This is not a statement about our ignorance of the system's true state. It is a statement about what the system actually is. The double slit experiment proves this. The interference pattern that appears when particles pass through two slits simultaneously requires the particle to have genuinely passed through both, not one or the other with unknown probability. The superposition is real. Now here is the problem. When you measure the electron spin, you get one result, spin up or spin down, not both. The superposition, which was real before measurement, is not real after measurement. The wave function collapses from a superposition to a single definite state. The other possibilities vanish. Where do they go? This is the measurement problem. It is the central unsolved problem in the foundations of quantum mechanics. The mathematical formalism of quantum mechanics contains no collapse. The Schrödinger equation, which governs the evolution of quantum systems, is linear and deterministic and produces superpositions. It never produces the definite outcomes that measurement produces. The collapse is added to the theory by hand as an additional postulate without any physical mechanism. It is a rule that says, when you measure, the superposition becomes one outcome. But the theory does not say how. It does not say why. It does not say what counts as a measurement. It does not say where the other outcomes go. This is not a minor technical detail. This is a gap at the heart of the most successful physical theory in history. Here is the analogy that makes the problem concrete. Imagine you have a coin that is genuinely, physically both heads and tails simultaneously. Not because you do not know which it is, but because the physical state of the coin actually contains both possibilities at once. The mathematics describes this precisely. Now you look at the coin, you see heads. The mathematics no longer contains tails. What happened to tails? Where did it go? The equation that was running, the Schrödinger equation, does not produce this disappearance. You added a rule that says looking makes one outcome real and the others vanish. But that rule is not in the physics. It is in your interpretation of the physics. Do you see what happens? Everett's solution was radical and simple. What if the wave function never collapses? What if the Schrödinger equation is always correct, always applies, never stops? What if when you measure the electron's spin and get spin up, the wave function does not collapse? Instead, it continues to evolve, and the branch containing spin up and the branch containing spin down both continue to exist. And you in the spin up branch are simply unaware of you in the spin down branch because the two branches no longer interact. The measurement is not a collapse, it is a branching. You become entangled with the electron. The combined system, you and the electron, evolves into a superposition of you seeing spin up with a spin up electron and you seeing spin down with a spin down electron. Both branches are real. Both contain a version of you having a definite experience. Neither branch is aware of the other because the quantum states of the two branches are orthogonal. They do not interfere, they do not communicate. They are, in a precise mathematical sense, separate worlds. The parallel universes are not added to quantum mechanics. They are what quantum mechanics produces if you take the mathematics seriously and refuse to add a collapse postulate that the mathematics does not contain. Now I want to take this deeper, because the many worlds interpretation is not just about quantum measurements in a laboratory. It applies to everything. Every quantum event in the universe, every radioactive decay, every photon absorption, every electron scattering is an interaction that the Schrödinger equation describes as producing a superposition. If the wave function never collapses, every one of those interactions branches the universe. The number of branches is not just large, it is incomprehensibly, incalculably vast. New branches splitting off at rates that make the number of atoms in the observable universe look like a rounding error. And every branch contains a complete, consistent, physically real universe in which every prior quantum event went the way it went in that branch. This is the part that keeps me up at night, because here is the personal implication, stated precisely and without softening. Every quantum event in your body, and your body is a quantum system running quantum chemistry in every cell, with neural firing events that may have quantum-sensitive components, with every metabolic reaction dependent on quantum tunneling and quantum electron transfer, is, if many worlds is correct, a branching event. The version of you that made the decision you made this morning coexists in the Everettian multiverse with versions of you that made every other quantum mechanically possible decision. Not hypothetically, not as a thought experiment, as a physical fact about the wave function of the universe. The you that is reading this is one branch. The branches you did not take are not counterfactual. They are real, in exactly the same sense that you are real. They contain complete universes with complete versions of your life, your relationships, your history, your future, all equally physical, all equally real, none of them accessible to any other, each one convinced that it is the real one. Now let's be honest about what many worlds does not solve, because intellectual honesty requires it. The most serious problem with the Everettian interpretation is the probability problem. Quantum mechanics makes probabilistic predictions. An electron has a 70% chance of being spin up and a 30% chance of being spin down. In the many worlds framework, both outcomes occur. So what does the 70% mean? In what sense is one branch more probable than another if both branches exist with equal ontological reality? This is called the Born rule problem, and it is genuinely difficult. Various solutions have been proposed: decision theoretic arguments, self-locating probability frameworks, but none has achieved consensus. The many worlds interpretation solves the collapse problem cleanly. It does not solve the probability problem cleanly. This is why serious physicists remain divided. Bring this back to right now, to the specific physical moment of you reading these words. Your neurons are firing. Each firing event involves ion channels opening and closing in response to voltage changes. The voltage changes depend on the positions of ions, which are quantum mechanical objects. The positions of those ions are, in principle, quantum superpositions until interaction with the surrounding environment decoheres them, collapses them, in practical terms, to classical definiteness on timescales of femtoseconds at biological temperatures. The decoherence is real. The branching, if ever it is right, is real. The version of you having this thought is one branch of a quantum mechanical wave function that also contains versions of you not reading this, having different thoughts, making different choices, living different lives in the same physical universe, separated from you not by space or time, but by quantum phase, invisible to you not because they are far away, but because the mathematics of quantum mechanics makes orthogonal branches unable to interfere with each other. You are not alone in the universe. You are not even alone in your universe. But here is what I find myself returning to when I sit with many worlds seriously. The branching, if real, does not diminish you. The version of you in this branch made the choices this branch contains. The joys and sorrows and relationships and decisions of your life are the joys and sorrows and relationships and decisions of this branch. Real, consequential, yours. The existence of other branches does not make this one less real. It makes it one of an unimaginable number of real things, each one locally complete, each one containing a full universe of experience and consequence and meaning. The many worlds are not alternatives to your world. They are the context in which your world exists. You are not a possibility that became real at the expense of other possibilities. You are a branch of a wave function that has been evolving since the Big Bang, carrying your particular history of quantum events, your particular sequence of branchings, your particular slice of the universal wave function. You are what the universe looks like from here. And here, if ever it is right, is one of an infinite number of equally real theirs. If this twisted your brain a little bit, good. That means it's working. I'll see you in the next one.